Today we're going to be looking at rate of change and slope. The rate of change allows you to see the relationship between two quantities that are changing. So to look at the rate, we're going to have the change in the dependent value, or variable, divided by the change in the independent variable. So if we take a look at these next examples, we want to calculate the rate of change. So here, I know this is my independent, this is my dependent. So if I want to look in the change of my dependent, say $11.85 minus $7.90. So then we would have 3 minus 2, because these need to match up and down as well. So if we take a look at this, if we do $11.85 minus $7.90, we're left with $3.95 over 1. So what this is saying is it costs $3.95 for each person. So let's look at the rate of change for this. This one is still my independent, this one's my dependent. So if we look at the rate of change, let's find 2 points. So here's 1, 2. So when my dependent is 50 cents, subtracted from when it's $1, and my weight is 2, versus when my weight is 4. So we're going to have negative 50 cents. 2 minus 4 is a negative 2. So if we do 50 cents, negative 50 cents divided by negative 2, we're going to get 25 cents. So that means the rate of change is 25 cents per ounce. So let's take a look at this last example. We have a point there and a point here. So we look at our rate of change. This is my independent, this is the dependent. The dependent on top, we have 2,500 minus the dependent, which is at 2,000. All over my independent, this one's at 0, minus my independent, which is at 30. So 2,500 minus 2,000 is 500, divided by a negative 30. So if we take our 500 divided by that negative 30, we end up with negative 16, and that's rounded 2 decimal places, 0.67 hundredths. So this means someone is falling 16.67 feet per second. Let's find the rate of change for each of these situations. A plant is 3 inches long when planted and 7 inches long in 8 months. So the months is our independent, inches is our dependent. So we can say 3 inches minus 7 inches. When we first planted, so that means that it's been 0 months compared to our 8 months. So 3 minus 7 is a negative 4. 0 minus 8 is a negative 8. So this is a positive 1/2. So what that tells us is that it's growing 1/2 inch each month. So let's take a look at this one. We have a group of ticket price is $48 for 4 people and $78 for 10 people. So our people is our independent, and the amount of money is the dependent. So if we look at, we have $78 minus our $48 over 78 for 10 people minus 48 for 4 people. So 78 minus 48 is $30 over 10 minus 4, which is 6. So our rate of change is 5. So that means it's $5 for each additional person. Now let's take a look at our slope. Slope is also another way to look at rate of change, which is, remember, the change in your independent versus the change in your dependent. So we have the vertical change divided by the horizontal change, which can also be looked at the rise over run, which is saying y2 minus y1 divided by x2 minus, x1. So let's find the slope passing through each of these points. So if I take a look here, now this is my x1, y1, x2, y2. So I take a look here, my y2 is 5, and I have to subtract it from my y1, which is 0. My x2 is 2, I'm taking that away from my x1, which is 0. So 5 minus 0 is 5, divided by 2. So I have a slope of 5 over 2, because I can't reduce that any further. So let's try this one. x1, y1, x2, y2. So we take our y2, which is 4, subtract it from our negative 2, x2, 1 minus 5. So 4 minus a negative 2 is 6. 1 minus 5 is a negative 4. But this can be reduced. 2 can go into both. So 2 can go into 6 3 times. 2 can go into 4 2 times. And we have a negative. So we have a slope of negative 3/2. So let's look at one more example. x1, y1, x2, y2. So our y2 is 5 minus our y1 of 0. x2 is 1 minus our x1, which is a negative 8. So 5 minus 0 is 5, divided by 1 minus negative 8 is a positive 9. Nothing goes into both 5 and 9, so those are reduced. So we have a slope of 5/9. So let's take and find the slope of each line from our graph. So now we want to look at the rise over run. So if we find 2 points on our graph, I have 1 there and 1 here. Rise over run, so that means from this point I'm going up 2. So I have a 2 over, and then the run means, well, we're going to the right. I'm going over 1, 2, 3. So we have a slope of 2. So let's take a look at this one. We have a point right there and here. So remember, we want to rise, which if we start here, we're actually going down. So we're going down 1, 2, 3. So we're going down, so it's going to be a negative. We're running over 1, 2, 3, 4. So our slope is a negative 3/4. So now let's take a look at horizontal lines and vertical lines. Horizontal lines have a slope of 0, and vertical lines have an undefined slope. So let's take a look and draw. Let's draw a positive slope. A positive slope, anything that's going in the positive direction. A negative slope, anything going down into the negative direction. So 0, remember, is a horizontal line. So this has a slope of 0. Vertical lines has an undefined slope. Let's find a slope between these 2 points. x1, y1, x2, y2. So y2 is 5 minus y1, which is 2. x2, which is 1, minus x1, which is 1. So 5 minus 2, is 3 divided by 0. And since we can't divide by 0, this is an undefined slope, which means it's vertical. Let's take a look at this one. x1, y1, x2, y2. So our y2 is 4 minus our y1, which is 4. divided by x2, which is 0, minus our negative, or minus 3. 4 minus 4 is 0, divided by negative 3. This has a slope of 0, so it's a horizontal.